right. Good morning, viewers. Here we have a problem, a wave problem, and the question says, ray of light is incident on a mirror M1, and after reflection is incident on mirror M2, as shown in the diagram above. Calculate the angle of reflection of the ray at M2. So the question says we should find the angle of reflection at M2. What is M2? From the diagram, we have mirror 1. There's a mirror that is positioned vertically, and there's another mirror that is positioned horizontally. And the two mirrors are perpendicular to each other, making angle 90 in between them. So this is mirror 1 and this is mirror 2. And the question says we should find the angle of reflection of the second mirror. So how are we going to start this? I'm going to use this same diagram. I don't want to redraw the diagram, so I'm going to use this one straight the way it is. And this is for JAM question. Those that are taking JAM, this is for JAM. So how do you solve this? We're going to first of all find the angle of incident in the first mirror, the angle of reflection in the first mirror. So after which we will now navigate our way to find the angle of incident and angle of reflection in the second mirror. So how do we get the angle of incident here? Remember, this angle 30 here is not the angle of incident. It's a glancing angle. So we need to use the glancing angle to find the angle of incident. So angle of incident is always between the incident ray and the normal. Okay, so how do we get this? Remember, from the normal to the mirror is 90 degrees. So 90 minus 30 will give 60. It means the angle of reflection, the angle of incident is 60 degrees. Okay, 60 degrees. So what next? Remember, the law of reflection states that the angle of incident is equals to angle of reflection. So if this angle is 60, definitely this one is going to give us 60 as well. So this is R, which is angle of reflection, is 60 degrees. Okay, so we have succeeded in obtaining the angle of incident and angle of reflection. So how do we now get the angle of incident again in the second mirror and angle of reflection in the second mirror? We are going to extend a line here, which is the same. We're going to extend a normal in the second mirror, and the normal is between this ray and this particular one. So how do we get that? I'm going to draw a line, extend a line here, and you can make it dotted. Okay, you can make it dotted. Okay, so from here we have a normal here. This is a new normal. Can we make it F, for instance? Okay, so here, how do we get this angle of incident and angle of reflection, which is the required angle we're talking about? We are going to say, okay, in our normal mathematics, we know that if this angle here is 30, 60, and 60, this one is going to be going to be 30 to complete 180, because sum of angles in a straight line is equal to 180 degrees. So this particular angle is 30 degrees. And if this angle is 30 degrees, it means this angle alternates this one. From the law of line geometry, we know that this angle alternates this one. So if this one is 30, this one is going to give 30. That's the new angle of incidence is is 30 degrees. So if this one is 30, this one is going to give 30 as well. Why? The law of reflection states that the angle of incident is equal to the angle of reflection. So here is 30, here is also 30. So from this question, it says calculate the angle of reflection of the ray at mirror 2. Angle of reflection. This is the angle of reflection in the second mirror here. So our answer is is 30. This question you solve like this when you are solving for JAM, you're solving for WAEC, OBJ, you understand. But if it is theory, you must solve with proofs and tell why the reasons are like that. The way I'm saying them, you must put them all together. So thank you so much. This is a very good channel. You can comment and follow. And more videos will be coming. Thank you.